Hi everyone, my name is Kristina. I work on the German digital identity wallet project in Sprint. I moved all the way from America to Germany to work on it. So yeah, digitization in Germany is very important. So why are we talking about this? The context is, so obviously regulation is not the only force, but so I've been working on this space for over 10 years, and this regulation actually moved the markets a lot forward. And basically what it says is, before the 2026, all European member states, obviously including Germany, have to provide these digital wallets to their citizens and residents. Yeah, they have to do it. So the member states will provide the wallets, but it is up to the private sector to provide the issuers and verifiers, and we'll talk about it. So how many of people here have heard about this wallet thing? Okay, roughly not half, but close to half. Great, thank you. So in a nutshell, what wallets do is this first bullet point in black. So securely request, obtain, store, delete, and share. Basically manage digital identity and digital documents, both offline and online. There are other features like pseudonyms, qualified electronic signatures, dashboards for transaction logs, wallet to wallet, but in a nutshell, it's all about these digital documents. So what are these digital documents? On the left-hand side, you see pictures of the use cases from European Union, the European Commission. Basically, any kind of documents that we have. So in Germany, the main thing that our project, for example, is starting to work with is the EID you have that you use the Ausweis app with. So digitizing that, digitizing driving license, digitizing diplomas, travel documents, e-prescriptions. There are a lot of use cases, so that's the idea. And regulations are, helpful. So the big platforms by 2026 will also have to accept this wallet to log into their service. So there most likely will be the future where you can log into your Amazon account with your wallet. So what is this ecosystem? So we'll first talk about the actors, and then we'll talk more about the technical components. So from the actors, it's somewhat simplification, but it is true that the three main actors is the provider and issuer who has the data about the user, and then the wallet that is in the hands of the user, and then their verifier or relying party that wants to use that data from the user to provide services to the user. So there's user interacting with all these three components, and what's important is this trust model part, in a sense that based on what does the issuer trust the wallet, and wallet trusts the issuer, and wallet trusts the verifier, and verifier trusts the wallet. And what's interesting here is the flow of data changes. So in traditional OpenID Connect, when user wants to authenticate into the relying party website, the user doesn't have the data to prove directly, right? So what happens is user gets redirected to an identity provider who has the data about the user, and after user consent, that identity provider sends the data directly to the relying party. Here, the data flow is through this wallet, who is supposedly in the hands of the user. So the idea is the provider pre-issues, pre-provisions the data into the wallet, and user can send the data from that wallet to the relying party. So that's the actors. Now, what does it mean from a technical perspective? So if you're wondering what the heck is this wallet, so it can be different deployment models. I think a lot of implementations are starting with native apps, but it doesn't have to be. So it can be all local, right, where key management and all that is happening locally on your device. But it can also be where you're using cloud components partially, or we're also starting to see more experimentation with entirely web-based wallet, where basically you don't have to carry your phone. Any browser can become into a wallet. And why this becomes possible, in a nutshell, asymmetric cryptography and the key binding, right? So when the issuer issues a credential into the wallet, it signs over a public key, a private key of which is controlled by the wallet. So one of the claims in this issuer-signed credential is the public key controlled by the keeper of which is controlled by the wallet. So what happens when the wallet wants to present that thing to the verifier, what wallet does, it generates a signature using that private key. So verifier gets two signatures, the issuer's signature and the signature of the public key that issuer attested. So that's basically what's being proven during presentation is that knock knock verifier, I still control the key that I control during the issuance. And if you trust the issuer bounds the credential to this key, so you should trust me, is kind of the logic that's happening here. So to the protocols. And what's very interesting is that when EIDAS-1 came over, all of the technical standards were written by European standards body called ETSI, if you're familiar with that. But what's happening now is European Commission is trying to rely on standards from W3C, ITF, OpenID Foundation, so more range of standards. So it's harder for the Commission, but I do believe it's kind of better for the ecosystem because ideally, Germans should be able to use their wallet, not just in Germany, but, and not just in Europe, but with, America, Japan, Asia, whatnot. So all this, we talked about the technical kind of framework, but has to be privacy preserving, secure, interoperable, very ambitious. The protocols that we've been designing, working for, it's the protocol layer, so basically the request response messages, how do you interact? That's OpenID for Verifiable Credential Issuance. It is being mandated by the implementing acts. And then, so that's a protocol. It's kind of a pipe, right? And how the data about the user is represented is what is sometimes called, what is called credentials. And how you represent that credentials is either selective disclosure for JWTs or MDocs. Basically, CBOR or JSON. And then when you present it to the verifier, OpenID for Verifiable Presentations, and the same credential formats as SD-JWT or MDocs. And the reason why I have vanilla or over the browser API in small letters is this is what I want to focus on later today to kind of plant the seed for this audience. To help us with security and UX challenges, the browser vendors have stepped up to provide an API to do it. So that's an interesting topic. So let's dive into the protocol layer, some design principles. As we heard from Daniel, designing secure protocols is hard. So the original impulse was, this is so different. We need a new protocol, but we made the decision to base this on OAuth and OpenID Connect. So a lot of security considerations you've heard from Daniel apply to this world as well. So we do get the benefit of that, 10 plus experience in that community. And then if you're wondering, why is there two credential formats? There were actually more. So they were like this, religious battles between how to represent user data. And we said, look, we don't want people having to implement multiple protocols depending on how they represent the data or how they sign the data. So that was a very important design principle to make this pipe that is agnostic of different formats on top of it. And as we said, asymmetric cryptography is very important. And when you have keys, you need to find the public keys to validate the signature. And there were a lot of, again, different people want to do different things. Some want to use X549 certs. Some want to have some new mechanisms like OpenID Federation. Some want to do blockchain, whatnot. Again, we wanted to be agnostic for that. And most importantly, the trust framework. In OAuth, you usually pre-register your client with a server, right? So when the client goes to the server, you already know the client identifier of that client, you know the redirect URIs, that's kind of the basic, security protection. But in this wallet ecosystem, if you imagine that the German wallet should be able to receive a credential from a Dutch issuer, and you should be able to use it in Italy, you can't have that pre-registration. That just wouldn't scale. So how to, enable that kind of trust at the first site, on-demand trust, that was a really, really big topic. So yeah, we wanted ideally for people to implement one protocol. There are a bunch of open source libraries already. In terms of security, we have 2 documents, Security and Trust and OpenID and Verifiable Credential. Daniel is one of the co-authors, and we do have a master thesis on the threat modeling. So digging a bit deeper, so for issuance, it is much closer to OAuth than other protocols because the client can be, native app, web, whatnot, and the issuer is a server. Issuer is capable of having this, server infrastructure. So what's happening is wallet gets an access token that is valid to receive a credential. It hits a credential endpoint, which is essentially a research server capable of issuing a credential. So I think that for this flow, like minimum changes to your existing OAuth infrastructure. And then, so certification code flow, we've already seen in a previous presentation, but basically the wallet starts a flow, issuer authenticates the user, wallet gets an access token, uses that access token to hit a credential endpoint, gets a credential. 2 interesting parts. One is, as we said, the cryptographic protection. Cryptographic key binding is very important. So when wallet takes an access token to the credential endpoint saying, knock, knock, I want credentials, it also sends this signed JWT proving possession of that keys so that issuer is not binding a credential to a random key. And also from a privacy perspective, there's this batch issuance of credentials happening. So this design of issuer wallet verifier is by design helps with issuer verifier unlinkability. But if user keeps using the same credential at different verifiers, it does not guarantee the verifier to verifier unlinkability. So what people try to do is they batch issue like 20, 30 credentials so user can either have pairwise identifier between the wallet and the verifier, or it's a one-time use credential. I don't know, it's pretty small, but basically pretty standard for certification request. Very standard. Token request, very standard. Credential offer is this not integrity protected thing where, again, when the wallet doesn't know where's the issuer can say, hey, wallet, I'm here. I want to offer you this. Would you mind starting the flow? It's kind of this, like a nice offer. And then this is the new part. The request to the credential endpoint, the proofs is what I just talked about, the proof of possession of this cryptographic key material, and response are basically these credentials encoded. A quick UX flow, if you're on the same device, you're in the wallet's asking, do you want to get this credential? Yellow part is the issuer. I get redirected to the issuer. Issuer authenticates me. I get the credential. I consent. I get the credential. Kind of already talked about it, but selected security considerations. If you search OpenID for VCI, you can get a spec. We have like 10 plus considerations, but important ones are, so what's happening here, in a current model, identity provider issues data directly to the relying party, right? So relying party, knows it's talking to the provider. But in this case, because the data flows through the wallet, there's a lot of trust that goes into this wallet. So that's why, there are a lot of regulations and requirements around this wallet component. But that's why it's also very important for the issuer to make sure that it trusts that wallet. Because, for example, even the branding is left to the wallet. Like my favorite example is if, let's say PlayStation issues a credential, like PlayStation's color is blue, but wallet decides to just use green, and that's like competitor Xbox brand color. Like you don't want that, right? Like that at that basic level. So 2 mechanisms we have to prevent that. One is wallet attestation. It's basically the client authentication that's already defined in OAuth. So in token request, you can authenticate the client. There are different mechanisms. So one of them is, the new one is wallet attestation. It's basically saying this wallet is not jailbroken. It's certified by the EU, like very basic checks. The second is key attestation. And what it does is when the wallet provides this cryptographic key materials, like Daniel mentioned that for Germany, BSI, there are requirements to have level of assurance high. So there are a lot of requirements on how those keys have to be managed. Like it can't be Strongbox, it has to be Cloud HSM, or there are different requirements. So to make sure that the keys are securely managed, that's how the key attestation is being used. Second, Again, currently, when provider sends an ID token to the relying party, it's fresh, right? It's one-time use, it's fresh. Here, these credentials are potentially multi-use, and they might have been issued a week ago, 10 minutes ago, or if the validity allows, like 3 months ago. So this credential lifecycle to prevent outdated credentials or fraudulent credentials to be used, issuer does have to take care of the status. This status management is actually pretty interesting too. We don't have time to dig deep, but one of the mechanisms emerging is bitmap-based, where on a byte map, basically each byte represents one credential, and you flip the byte from 0 to 1 when credential gets invalidated. And the last one, if the issued credential is bound to a key controlled by the attacker can just present and impersonate you. So making sure that the key actually belongs to the user, but I think we've already seen that. Just a small deviation, but how the keys are stored in this architecture is an interesting topic. We spent almost a year in this German EUDI Wallet project digging deep into it. So first option, the most straightforward option is your phone has a hardware-bound keys, secure element on iOS, Android has Strongbox storing the keys there, right? Whether that meets level of assurance high, still the question. That's option 1. Option 2 is your EID card has a chip, right? It stores the keys. So kind of using that to derive the keys, basically. But that means that you have to tap that card, physical card, every single time you present the credential. Not a good UX. Maybe the balance is use the cloud HSM, where the data, user data, is encrypted on device, handled on device and everything. But for this signature generation, you could use a cloud HSM. So if you haven't heard, the German government actually made 2 big announcements 2-3 weeks ago. So first one was that for this wallet ecosystem, there will be a marketplace, basically, in a sense that there will be a government-provided wallet, but there also will be private company-provided wallets, as long as they are certified and they meet all the requirements. So, if startup is capable of, startup can have a wallet. If Google Wallet wants to be an official European digital identity wallet, like if they meet those requirements, theoretically they could. And the second announcement was that the German government is building that wallet, and the architecture it's starting with is number 3, the cloud HSM, and it uses the signed data. So if you're curious, happy to deep dive, but that's a bit deviation from the topic. Quick privacy considerations. I already talked about the batch issuance. That's how this verifier to verifier correlation is being prevented. Another interesting piece here is potential use of zero-knowledge proofs. So from the EU perspectives, this hardware binding, the fact that the key for level of assurance high credentials are, hardware bound was very important. And a lot of zero-knowledge curves and algorithms are not supported in the secure areas right now. So that was one of the hurdles. But there are potentially ways to do like Ziggy circuits with ECDSA. So that's where some of the innovations is very, very actively happening right now. Now to the presentation. So that's after wallet got the credential, how the wallet presents it. Very basic one would be the redirect, right? The verifier sends the redirect authorization request, receives the credential back. We don't really see this actually being implemented because of the size limitations of the URLs in the browser. And these credentials, they're 2 signatures, so they could get pretty big. So just the really basic OAuth redirect examples, same device. The use case is basically I'm browsing the browser on my phone. It redirects me to the wallet, back to the verifier, and that's how I get access to the service. This one is much more interesting. So, but main use cases are I'm browsing, let's say I'm on Amazon on my laptop, and Amazon's like, hey, authenticate yourself, and my credential is bound to a hardware key on this phone, right? Like, what do you do? And the OAuth right now did not have a solution to that, so we had to create a new grant type that we call direct post, where basically after the wallet gets the authorization request, the response is being posted. So it's HTTP post. It's being posted from the wallet to the verifier's endpoint. And if you have noticed, this opens up a really nice security attack, because basically session fixation, in a sense that what becomes possible, I as an attacker go to the website, create the request, have a QR code, replay it, trick the victim to scan that QR code, because it's not redirect. If you have a redirect, you can set a cookie or session, and you can make sure the response is coming back to the same session as a request. But if response is the post, you can't really do that. So if a victim posts from victim's wallet to the Verifier's backend, Verifier has no way to know that it's a different user, right? Unless we have some kind of proximity checks, which we'll talk later. So it's kind of, we need it because main use cases are this scenario, but there are also some known attacks, right? The only change for the request is the response mode is direct post. And as you can see, like very simple, the response becomes the post, HTTP post. Screens, we probably already get an idea, so I'll quickly skip it. The second point is what I already mentioned, session fixation in response mode, direct post. So I'll quickly cover point 1 and 3. Point 1 is the replay of credentials. So what if, I'm just putting my mom's credential in the presentation. To prevent that, we're binding credential to a transaction using a nonce parameter, an audience, very basic, same as ID token replay prevention. Third one is, it used to be a bit controversial, but I think now it's more accepted. So situations where when the wallet posts and TLS protection ends before the credential reaches the target application at the verifier, or if attacker steals the data. If it's encrypted, attacker can't read it. If it's encrypted, the application has to decrypt it directly, so encrypting the response is one of the protections. So I'll skip these because I want to talk about this. So we're getting help from the browser vendors, Google and Apple, and it's kind of like love and hate negotiation, in a sense that, like, we obviously can see that Google and Apple want these, high assurance government-issued credentials in their wallets, but at the same time, we kind of need their help in terms of the platform. So kind of trying to separate them providing the platform tools, APIs, and browsers and mobile operating system versus them actually building the product on top of it. So two benefits from security. As I already mentioned, the cross-device flows are pretty insecure, so we need help securing that. And from a UX perspective, some of you might be familiar, but especially on iOS, if you have multiple applications that are capable of handling the same credential, in this case, capable of responding to the same request, the user does not get a choice of application. Basically, if there are 3 applications, the last application automatically gets popped up, or it's like very unreliable. So we really needed help with this wallet selector, where request comes in, and let's say, user has 2 wallets where it stores different credentials, and user gets a choice. Which one do you want to use, basically? And if you're familiar with WebAuthn, passkeys, FIDO, that is basically the mechanism that is being leveraged here. So what happens is the verifier, ignore the verifier backend. So verifier JavaScript running in the browser sends an API request to this new browser API built by browsers, Google and Apple, basically. And the platform passes that request to an app platform. So that has to work between Chrome and iOS, Safari and Android, not to mention, Chrome Android and Safari iOS. So they pass that, and this is where they apply this security check, where they ensure the device where the browser is running and device where the wallet sits are in proximity. It's reusing CTAP hybrid. So the replay attack I described earlier becomes very, very harder because it's Bluetooth, so the range is like not the widest. So if attacker creates a QR code and is trying to trick the victim to scan it, the victim has to be in a very, very close proximity. So, hopefully we're solving majority of those. So that's kind of basic. Then And after that proximity is ensured, the user gets a pop-up. It's not a consent yet. It's a first pop-up saying, hey user, you have multiple wallets that can meet this request. Which one do you want to use? And only after the user selects that wallet, the wallet application gets an actual request. So it's also hopefully, a better privacy guarantees, because the wallet doesn't get a request until the user selected the wallet. And after the wallet gets opened, user is in the wallet, user gives consent in the wallet and all that. Wallet returns this credential to the app platform passes this back to the browser platform, and basically from the verifier perspective, I do a browser API call and I get it back. And the big fight we've been having with Google and Apple for the past 2 years is basically, how does this request response look like? And the current agreement, consensus, compromise is browsers build this pipe. From Google perspective, they're very clear it's going to be a very dumb pipe. They're going to help, between the verifier application and then browser platform and mobile operating system, mobile platform, and then the wallet. And they pretty much don't care what goes through that pipe. And that's where you can stick in your OpenID for VP requests that many people have implemented without the browser API already, so it flows through, right? With Apple, they're kind of, with grinding teeth, agreed with this. How dumb Apple's pipe is, you'll see. They might apply a bit more checks, checking whether the API request from the verifier application web app is well-formed or not. So that's, we'll see. But that's kind of a very big movement. So I think in the few years, we'll see a lot of applications using this API, because security and UX improvements are just so clear. And you can send either signed or unsigned request. And the signed part is very important. If it's unsigned request, your security guarantees is matching the origin in the request from the verifier and an origin that the platform provides you. So you match it. If it's the same, there's no man in the middle. But on top of it, European Union wants to sign it because additional trust frameworks. Maybe you have an X5 or 9 chain behind it. Maybe you have this EBSI, the blockchain chain behind it. Or maybe you have OpenID Federation behind it. But as you can see, the example code I put there is await navigator.credentials.get. So it's literally extension of WebAuthn. So I don't have time right now, but we talked about the protocol mainly, and these thingies that you can put on top. One of them is SD-JWT, basically JWT, but with selective disclosure. And so Daniel and I have been working on it for a long time. And how we did it is, if you're trying to selectively disclose things within a signed credential, you're breaking the signature, basically, right? So what we did is these things. So this is your payload. You create an array with sold, claim name, claim value, and you hash it. And you put those hashed values in an issuer signed credential. So issuer signs over the hashes. So even if you get it entirely, you don't know what was the plain text just by getting it. What you need to decode it is these, what we call disclosures. So basically, this array of sold, claim name, claim value is being base64 URL encoded and being appended to this JWT. So on the left-hand side, you see a usual JWT and tilde separated disclosures, which are basically base64 URL encoded version of an array before it's being hashed. So this is what you get as a verifier. The red part is a JWT with the red part is JWT, green part is these disclosures, and key binding JWT is basically the second signature I've been talking about, the proof of possession part of the signature. And how you process it, and don't have time to get into security considerations, but basically you have to do all these checks. If you do them, you're very secure. You decode the JWT. This is how it's going to look like. And then you would decode these disclosures as well. And now to do the full selective disclosure, what you need to do is you hash this array, and you see if you can find that hash within the JWT you just decoded. So the very first claim within the JWT, you can see _SD. That hash value matches with the hash value I just got by hashing the disclosure. And then I do the key binding JWT. So you can see the confirmation claim in the very top jot. That's basically the user's public key, right, that credential is bound to. So what you do is you use that public key to make sure the key binding jot signature is signed using that key. So I'm sorry, I wish I could have spent more time on this, but that's kind of the nutshell. I saw some people smile and nod, so I think it's straightforward enough. Literally, people implement this in like weekend projects. So if you're bored, try it. But yeah, thanks everyone.
Thank you so much, Kristina. We do have time for one question before we have the next speaker, if you would be so kind and queue up in the front. But that's fine. The next...
Oh, there's one question.
Please queue up in the front if you have a question.
Yeah, my question would be, how confident are you with the timeline that in the end of 2026 we will have a secure implementation of a digital wallet?
I think we'll have a first iteration of it. Like, I agree with you, it would be very ambitious to have a wallet with all those features. But for example, Germany is starting with making sure the digital version of EID is securely stored in the wallet. So I am pretty confident you have that, at least as a feature by 2026. How useful that is a different question, but the idea is really have those like iterations. So first starting with digital version of EID, then putting more like digital driving licenses, digital diplomas in there. And last step is more complicated topics like how does that wallet do QES, qualified signatures, or how do you do pseudonyms, or like payments are even in scope, right? So that's how we're thinking right now. So yeah, probably not everything before 2026, but hopefully something.
Thank you so much, Kristina.
Thank you.